So in this video, we're going to be talking about absolute values in inequalities form. So last time we talked about absolute values, you remember me talking about when you have an absolute value and equals some number, you have to solve it by splitting it into two equations, one with the positive value and the other with the negative value. So then you can try to get x by itself. So one of the key parts about absolute values is that you have to consider the positive and the negative value. Same thing if we were to switch out the equal sign for an inequality symbol. So in this case, we have to also consider the x being a positive value, let's say a is some number, and also that it could have been a negative number. As we get into this lesson, I do want to mention that when it comes to absolute value as an inequality, so when you represent it with these inequality symbols, it gets a little tricky and we have to put them in certain categories. So let's start with when you have an inequality symbol with a greater than symbol. So that means that the inequality is facing towards the x or towards the absolute value. Anytime you have an inequality that's facing towards or is greater than, then that means that you have to separate it into two equations. So what that might look like is, let me write this out. Oops, that's a highlighter. As x is greater than positive 3, so we drop those absolute value signs, and we're going to represent with the positive 3 first, and then we also need to represent the negative 3. But one of the things that we've learned is that anytime you switch the signs, the negative sign to positive or positive to negative, you also have to flip the inequality sign. So it's now going to be facing towards the number. So anytime you have the inequality facing towards the absolute value sign, that means you're going to split it or you're going to separate it into two equations like this and then have an or between it. So how I remember, this is going to sound really silly, but anytime it's facing towards, it's two equation. Towards looks like the spelling for two, so that's how I can remember. Anytime I see it facing towards, I remember two equations that I need to split it up to. So that is how you would write the inequality symbol. If you were to graph this would be, you would graph negative 3 first, because that number comes furthest on the left. And then you would have closed circles because both of them uses the inequality with a line. And this one says x needs to be less than negative 3. So numbers that are less than negative 3 are facing towards the left, towards negative infinity. And this one says x needs to be greater than 3. So those are numbers that are moving towards the right, towards positive infinity. So that would be the graph. All right, now that we've kind of gotten an idea of what to do when the sign is facing greater than or facing towards the absolute value sign, let's try to solve some problems that are in that condition. So like this one here, it says to solve the absolute value, and you have to write it as an inequality, so like this symbol here, and as an interval. So if you remember intervals, those are those brackets and parentheses form. So let's first start with just solving it in general. I want you to notice that this inequality is facing towards the absolute value sign. So if it's facing towards, you need two equations. So let's split this guy up into two equations. So this will be 2x plus 1 is greater than positive 7, or 2x plus 1 is less than or equal to negative 7. So once I split it up into two equations, I can drop those absolute value signs and start solving this. So let's start off with the first one. We need to subtract the 1 to both sides. 2x drops down. 7 minus 1 is 6. If I divide by 2, I get rid of those 2's. And I divided by a positive 2, so I don't need to switch the sign, so I'm just going to carry that sign down. 6 divided by 2 is 3, and now my x is by itself. I'm going to carry down this or, and now I'm going to solve this guy here. So again, I have to move the 1 over, so subtract the 1 to both sides. 2x drops down. Negative 7 minus 1 is negative 8. I need to divide by 2. And so x is less than or equal to, let's see, -8 divided by 2 is -4. So it looks like my answer is x is greater than 3 or x is less than -4. Now, we're not finished because we do need to write the interval notation. Now, I don't know about you, but for me, I can't write the interval notation without seeing the graph. It makes me more comfortable to know what the graph looks like, and then that helps me a lot when creating the interval. So I'm going to drop down my -4 and my 3 because those are the two numbers I'm given. I put them in order, and I'm going to put a closed circle because the inequality has a line. Now, when I look at the -4, notice that x is less than -4. So that means I need to be going that way because these are numbers that are less than -4. So I'm going to -infinity. Whereas this one says x is greater than 3. So these are numbers facing towards the right, going to positive infinity. So this is going from -infinity to +4 and 3 to positive infinity. So I'm going to put a U for union because there are two intervals here. Let's see if I can box that in nicely. And so now I have my inequality and I have my interval form. So see if you have a hard time making the interval notation, then draw a graph, and that really helps people out. All right, with this next one here, I want you to notice that, yes, it is facing towards the inequality, but we can't separate them yet because there is a 2 in the way. So if you remember, one of the fundamental rules with absolute values is that you have to get it by itself. So this absolute value is not by itself. There's a 2 here, so I have to divide by 2 to both sides first before I can start separating them. Once I have it by itself, let's see, 10 divided by 2 is 5. So once I have it by itself, then I can go ahead and see that this absolute value is facing towards, the inequality is facing towards, so I'm going to separate it into two equations. So this would be h plus 5 is greater than +5, or h plus 5 is less than -5. And then from there, I can start solving. So I might subtract 5 over to both sides. And so h is greater than 5 minus 5, which is 0. And then this side here, h is less than -5 minus 5 is -10. And so here is my final result, because now I have h by itself, I have the variable by itself. And now I need to write the inequality. So I'm going to again do a graph here to help me visualize where my intervals are, or where my shaded region is. So they both need open circle because this inequality doesn't have a line underneath. Now this one says h is greater than 0. So if h is greater than 0, that means numbers are greater than 0 are facing towards the right. So I'm going to be shading towards the right, towards positive infinity. Whereas the other one says h is less than -10. So numbers less than -10 are facing to the left, towards -infinity. So my interval is from -infinity to -10 with not a bracket, with a parentheses, and then 0 with a parentheses to positive infinity. And there we go. We have our interval notation. All right, in the next video, I'll explain what to do when you have a less than symbol, but hopefully that helps you understand how to deal with greater than when you have absolute values.